In this video, let us solve problems based on surface areas and volumes of combinations of solids. That means, we're going to have like a cylinder and a cone, joined, something like that. So it says that an iron pillar has some part in the form of a right circular cylinder. The lower part is the right circular cylinder and remaining in the form of a right circular cone. The top part is the right circular cone. The radius of the base of each of cone and cylinder is 8 centimeters. The radius of the base, that is here, of the cone as well as the cylinder is 8 centimeters. And the cylindrical part is 240 centimeter high, as you can see here, and the conical part is 36 centimeter high. Now what we have to do is we need to find the weight of the pillar if 1 cubic centimeter of iron weighs 7.8 grams. So all that we have to do is, how do you find the weight of the iron pillar if 1 cubic centimeter of iron weighs 7.8 grams? So you first have to know like how much of iron is there. That means what? What is the volume of iron in this whole solid thing that is given here? So all we have to do is just find the volume, and once you find the volume of iron, multiply it by 7.8 grams to get the total weight, because 1 centimeter cube weighs 7.8 grams. So whatever volume you find, that times 7.8 gives you the total grams or the total weight of the entire thing. So let's start to solve the problem. So first of all, we've got the data very clear. Let R1 and R2, there is only R1 which is 8 centimeter. Let the base of the cone be R2 centimeter, R2. R2 equals 8 centimeter. Although it doesn't make a difference since they are both equal. But also, we'll have R1 equals R2 equals 8 centimeter. Note carefully, take notice of the fact that R1 is the radius of the cylinder and R2 is the radius of the cone. And then let H1 and H2 be the heights of the cylinder and the cone respectively. Okay, so H1 is the height of the cylinder and H2 is the height of the cone. That's one thing you need to know. So now what we have to do to find the total volume is nothing but first find the volume of the cylinder and then find the volume of the cone and then add both the volumes. That's all we have to do. So let's start off with the volume of the cylinder. Before that, let us also quickly mention that H1 is nothing but the height of cylinder, and H2 is nothing but it is the height of the cone, right? So now let us find the volume of the cylinder first. Okay, so volume of cylinder is given by pi r square h. In this case it is pi r1 square h1, because the radius of the cylinder is r1, so therefore it becomes r1 square times h1. Since it's the volume, it will be centimeter cube, right? So now substituting the values, so let's keep pi as pi, and then we've got the radius is 8, so since it's r squared, it is 8 times 8. The height is 240. The whole thing is centimeter cube. So yeah, now what we've got is, we've got pi times 64 times 8 times 8 is 64 times 240, which is already there, centimeter cube. So this is the volume of the cylinder. The reason we need to just keep it like this is going to be easier for us to calculate in the further. It's not going to be difficult to add up big numbers, and then you don't have to waste your time multiplying such big numbers. So that's one thing. This is like a time saving technique here. And the next step is what? Now that we found the volume of the cylinder, let's find the volume of the cone now. So volume of the cone is 1 by 3 pi r square h, right? So in this case it is r2 square and the height is h2. It's not simply h. So let's substitute them all. The volume of the cone is 1 by 3 times pi times the radius is 8, so it's going to be r square, so it's going to be 8 times 8 times h2 is 36 centimeters, so times 36, the whole centimeter cube, right? So now let us find the total volume of the iron. So the total volume of the iron is nothing but, the volume of the cylinder. Let's take it as VC, and the volume of the cone, let us take it as VCO, and let's take the volume of the cylinder as VCY, because since the first letters are the same, so it's going to be VCY plus VCO. That is nothing but the volume of the cylinder plus the volume of the cone. Volume of the cylinder is given by pi times 64 times 240 plus volume of the cone is given by 1 by 3 pi times Again, we get 8 times 8, which is 64, times 36, the whole centimeter cube. Remember, we need to add in between, right? So now, considering both the terms, we've got pi times 64 as common. So we can take out pi times 64 multiplied by 240 plus, now 3 goes 12 times and 36. So it's going to be 240 plus 12 centimeter cube. Use the value. Now the value of pi is 22 by 7 times 64 times 240 plus 12 is 252. Right? So 7 goes 3 times in 25. That is 7 3 times is 21. 4 remainder 42. So 7 goes 6 times in 42. So that is 36. So multiplying 22 and 64 and 36, we get something. Alright. So again, we don't have to multiply just yet. You just can say that this is the volume, the total volume, or let us multiply it. So we get, multiplying these, you get 50,688 centimeter cube. So this is the total volume of the iron pillar here. So what you have to find out eventually is, you need to find the total weight of the pillar if 1 cubic centimeter of iron weighs 7.8 grams. If 1 cubic centimeter of iron weighs 7.8 grams, and how much is 50,688 centimeter cube of iron going to weigh? You just have to multiply 50,688 by 7.8 grams to get the answer. Right? So now, let us find the total weight of the pillar, which is going to be 50,688 times 7.8, because this is so much of centimeter cube. 1 centimeter cube weighs 7.8 grams. So this is going to weigh exactly 395. If you multiply these two, you get 395, 366.4 grams, which is equal to 395.3664 kilograms, because 1 kg equals 1000 grams, and you divide this by 1000, you get this. So therefore, the total weight, the weight of the pillar, if 1 cubic centimeter of iron weighs 7.8 grams, is 395.3664 kgs. So that's all. It was a pretty simple problem in the end. All we had to do was, whatever we were doing separately, we had to combine it here. Find the volume of the cylinder first, and find the volume of the cone. Add the volumes, and you had this 1 centimeter cube of iron weight is so much. So you just have to multiply by the total volume of iron to get the total weight. That's all. So this ends this video. I will see you in the forthcoming videos with more problems based on surface areas and volumes of combinations of solids.